Fundamentals of Wind Power, Wind Energy System Components, Chapter. The topical overview includes wind turbine structure with the following elements: blades and hub, nacelle, gearbox, generator, brakes, tower, onshore and offshore foundation, the control system, and then a summary. In the photograph to the right, you'll see the rotor at the top of the tower assembly with the attached blades, the nacelle on the back side, which has the turbine housing. We have the tower itself, and then we have the foundation at the base. Blades and hub. The blades attach to the central hub. It rotates when an aerodynamic force is exerted upon them by the wind. Three blades are the favorable formation because it takes sufficient energy out of the wind and functions in a stable way due to changing wind directions. It has a similar functionality and design as an airplane propeller or helicopter rotor operating in reverse. The structural advantage to having fewer blades over a larger chord, width and length of wind turbine blade, is due to the stresses on the chord. Blade manufacturing methods include wet layup. Multiple layers of fiberglass cloth are placed into a mold. It's rather labor intensive, hard to ensure consistency, and a potential health hazard to workers. Pre-preg, fiberglass has been injected with resin that stays firm at room temperature. Consistent resin to glass ratio. However, material cost is expensive, along with the provision of heat for larger blades. Resin infusion. Dry fiberglass cloth placed into mold before resin flows into the glass. Toxins byproduct are not released into the air. Compression molding. Most useful for small blades. A method of heating fiberglass and resin together in a two-part mold. Pultrusion. Material pulled through a die to form specific cross-sectional shape, though shape has indefinite length. Suited for vertical axis wind turbine. Wood epoxy saturation. Similar to the wet layup with fiberglass, except with wood. Plywood provides stiffness, greater blade thickness. Filament winding. Glass fibers wound on a mandrel while resin applied. Results in a consistent product. However, difficult to use with concave shapes and to align blade fiber along the length of the blade. Blades attached to the hub, which connects to the drive shaft for transmission of rotational energy to the electrical generator. Hubs and blades often considered the rotor assembly. A cast iron alloy, often used to fabricate hub, may fracture due to carbon content. Rotor assembly must resist metal fatigue and failure, which may be difficult due to the welds and fasteners. Hub types. First, rigid hubs. Most common design for three-blade turbines. Rigidly attached to rotor hub where no degrees of freedom. Next, teetering hubs. Motion occurs between blade connector and main shaft, commonly used with two-bladed turbines. Finally, hinged hubs allow independent motion relative to the plane of rotation, not common on commercial wind turbines. Nacelle. Central enclosure which contains the drivetrain, that's the gearbox, generator, and control system at the tower's top. It is a lightweight cover which protects the contents from the weather. Assembly yaws to catch the wind from any direction. Typically created using lightweight materials such as fiberglass or thin-gauged metal. For larger turbines, maintenance crews can safely inspect and maintain the internal components. On smaller turbines, some type of covering is required to house components, but not as comprehensive. Gearbox. The gearbox transfers a low-speed, high-torque blade rotation hub into high-speed, low-torque motion for the generator. This is required since the rotor and main shaft run at much lower speeds than required by the generator. The gearbox tends to be costly, approximately 25% of the wind turbine unit cost. Most wind turbines use a single input, single output shaft configuration. However, for example, the Clipper Wind Power's Liberty wind turbine uses multiple output shafts to connect to multiple generators.